Welcome to Identifying Quadratic Functions. Okay, our objective today is to identify quadratic functions and determine some characteristics of the functions. This is not all the characteristics we're going to do, and we're going to actually do more of these as we go through this, but this is just kind of the beginning. We also want to be able to find the domain and range from the graph of a quadratic function. Hugely important, because that's something that you're going to see in a lot of questions within the course. So that's something, like I'm saying right now, make sure you understand, okay? And can you describe, for your BQ for today, can you describe a way to remember some of the characteristics of a quadratic function? How would you go about, like, maybe creating some type of way to remember these things, okay? Because that's actually kind of decently important. So, anyways, let's move on. So, a quadratic function, and this is something y'all have been getting confused about lately, but you're going to see it so much you're not going to get confused anymore, is a function with an x squared. The highest exponent is a square. So the parent of that is y equals x squared, and would look something like this, where you would say this graph that has a curved shape that's called a parabola. So let's make sure we remember that is called a parabola. So do not forget, this curve is called a parabola. Parabola. Not parabola, but parabola, okay? Okay, if you look at the table of that, you would see, say, -2, like if I went with points -2, -1, 0, 1, 2, and we're going to kind of use those x values at the beginning. We might change it up later, but for now, that should hopefully let you see both sides of the quadratic. And the reason why I say there's sides is because every quadratic has a vertex, and we'll talk about that more later. So,
Have you graded it, sir?
well, if you heard just now, you could hear Jose coming in asking if I had graded something, because, well, you know, he's the center of the universe there, and I just had to make sure I had everything graded for him when he could have waited. Anyways, the way we can tell from a table, looking at if something's quadratic, we talked about differences before, where we said, okay, let's subtract and see the difference for the x's is 1. And that the difference for the y's is -3, 1, -1, 1, 3. Notice that these are all different. And then if you look at that and you start thinking, okay, well, I know this is not linear, because this is what we used to do for linear. Well, for quadratic, we go, okay, I understand that we got these y differences right here and got that. But let's do a second difference. In other words, subtract again. What's -3 minus a -1? Or actually, -3, yeah. You should get that it's going up 2. -1 to 1 is going up 2. 1 to 3 went up 2. Notice all those are the same. So when the second difference is the same, you know you have a quadratic function. Okay? And again, all quadratic functions have that x squared value. That's your highest exponent. Okay, so is the following data quadratic? Well, if you're looking at a table, again, notice that the x's are changing by 2, so that's okay. I don't even worry about that. The y's change by -6, -2, 2, and then 6. So they're all different. Then I look at the second difference. So -6 or -2 minus a -6 is 4. 2 minus a -2 is 4, and 6 minus 2 is 4. So the second differences are all the same, so yes, that is quadratic data. For the other one, that's a set of points, I would go ahead and put it into a table, and then again, look at the first difference, and then get the second difference, and they're all 2, so yes, that's a quadratic function also. So hopefully, again, if you have any questions on that, you need to make sure you ask. Okay, so let's look at the next part. Graphs of quadratic functions. Let's start off with the parent function. And notice, for a table, like I would have wanted to fill in a table first before I make my graph. Start off with -2, -1, 0, 1, 2. So with quadratics, I want 5 points. That way we kind of get a nice balanced view. Now, you can square all those numbers, and this is what you get. 4, 1, 0, 1, 4. Plot those points, which is what you're seeing me do, and there's your graph. Now, in every graph, we can actually pull out some characteristics, and these are just the beginning. We're going to actually do more. We can see that it opens upward. It faces upward. All the points are going up, so it's facing up. Okay, that's something to make note of. This center point at 0, 0, every parabola has like a center point. That's called the vertex. The vertex also represents a maximum or minimum, but we'll talk about that more in a second. The vertex here is at 0, 0. And then I can talk about, is this the lowest point or is this the highest point? This is the lowest point. The vertex represents the lowest point. It's going to either represent the lowest or the highest. In this case, the lowest. Not a very hard thing to make notice of. So that would be considered a minimum. And the minimum is always the y value of the vertex. That's very key. The y value of the vertex. So the minimum here was 0. Okay, so you can have, the vertex will either be a maximum or a minimum. Don't forget that. We've got plenty of examples of this. Okay, so here's an example, 4 times x squared. So I would square all those numbers and then multiply by 4, and I would get those answers. Plot those points. And you can see the plotting of the points right there. So I'm going 0, 0, -1 and +1, 4, and then -2 and +2, 16. Okay, faces upward. It would be, the vertex would still be at 0, 0. And that is a minimum at 0. Okay, another example. So I'm going to go through these examples quick. If you have questions, feel free to ask later. Y is equal to -x squared. All that would do is make sure that you square them and then make them answers negative. So like -2 squared is +4, but then it would be -4. Oops, skipped a spot. So you can see here, -4, -1, 0, -1, 4, and you can see my points trying to make my upside down U. Notice that a negative flipped it downward. That might be something key to remember for later. The vertex was still at 0, 0, and the max, now notice this is a max now because it's facing downward. So this is the highest point. The vertex represents the highest point, and it's at 0. Okay, next one, x squared minus 3. So if I square -2, I get 4, and 4 minus 3 is 1. -1 squared is 1, 1 minus 3 is -2. 0 minus 3 is -3, then again -2, and 1. Do you start seeing a pattern here that some numbers will repeat? That's called symmetry, and that's something we'll talk about more later. Okay, so here's the graph, and you can see my different points. Notice it is facing upward. The vertex is now at 0, -3. So that, and notice it is upward, so you do have a minimum, and that minimum is -3. Okay, one more example. -x squared plus 2. So again, -x squared means -2 squared is 4. Make it a negative, plus 2 would give you -2. And you can kind of see how that works. See how it looks. Okay, notice this is facing downward. The vertex is at 0, 2, and that's a max value of 2. Again, the max or min value is always the y coordinate of the vertex. Do not forget that. All right, so now we've only got a few more examples, and I want to look at domain and range. Again, remember, domain is your set of all x's. Range is your set of all y's, so all the possible x's and y's. Now, the way we're going to do this is, because the quadratics work a certain way. So if we look at this, okay, domain and range, let's see here. Let's look at this. So the domain is the set of x values. Okay, is there a limit to how far I can go to the left or to the right? No. So then for that, I'm going to say it's this symbol right here, which stands for all real numbers. Means any number could be your x, which would make sense. Honestly, that should be your answer for pretty much all the time for quadratic functions. Now the range, though, is something special. Here, you notice the y value. We're starting here, and we're going up. Okay, so how do I show that? Well, I can say y is greater than or equal to what number? 0 because that's as low as it goes. So y is greater than or equal to 0. So there's your range. See if you see a pattern that should hopefully make this a little bit easier. Let's look at another one. Here you can see there's a domain and range. Look at your vertex. Notice the vertex is 0, 6. Okay, your domain is, again, all real numbers, but your range, it's going down. What makes you think down? Less than? Yay, probably a good try. And less than or equal to? Notice there, 6. So you see a pattern? Hopefully you do. All right, last example. Here we go. My vertex is, notice I'm finding the vertex first. I hope to find my vertex. There we go. -4, 4. Okay, my domain, again, is all real. My range is greater, because it's going up, than -4. Okay, so do you see a pattern between the y value of the vertex and your range? Hopefully you do. Anyways, that covers everything there. If you do have questions, I hope that you wrote them in the notes and that you will ask me later. But that's it for today. I will see y'all when I see y'all. Hopefully you'll have these.